Good morning and welcome to today's webinar, How to Avoid Time and Cost Overruns on Mining Construction Projects. This one's been presented by Tom Kendall. My name is Aidan Montague and I'll be your moderator for today's webinar. I'll hand over to Tom shortly, but first just a little housekeeping so that everything runs smoothly. First of all, the main presentation will last about 25-30 minutes, and then we'll have 10 minutes or perhaps more of Q&A at the end. So the entire webinar is expected to last about 40 minutes, depending on the number of questions that we get. Now, you'll have an opportunity to ask Tom questions during the webinar, but these will all be answered at the end. You should see a question pane on the right of your screen. So just type your questions in there as the webinar proceeds, and during the webinar, you'll be muted. So let's get started. And first of all, I'd like to introduce Tom Kendall. I think you all know that Tom has a wealth of experience in the mining industry. He's a consulting engineer with 45 years experience in mining and heavy industry. Tom's an experienced design engineer. He's been engaged in the entire project development process. And of course, he also has enormous experience in feasibility studies from scoping right through to bankable studies. So now I will hand over to Tom, and I hope you enjoy the webinar. Over to you, Tom.
Thanks, Aidan. Welcome, listeners, to this Mintrex webinar. I'll preface my comments with the clarification that what I'm presenting reflects my experience with project promotion and development, and particularly the early stages of that process. Have we not got my is that presenting now?
Sorry, Tom, you're all good now. Thanks.
Excellent. Right, so we have it. So it's not a complete analysis of the requirements of the project success. Rather, it considers common shortcomings that will occur from time to time. I thought we'd start with a look at the Australian Institute of Project Managers survey in 2020, which was done with KPMG, and it's not encouraging. It shows that about half of the projects didn't satisfy the stakeholders or meet the original goals, and less than half were completed on time or on budget. Now, there's two aspects to this survey. First question that needs to be answered is were the stakeholder expectations or the original goals realistic? Was the original budget and duration realistic? If they were, then the second question is what caused the underperformance? This is my list of root causes, and it's not rigorously researched, simply a reflection of my experience. But in a nutshell, problems in a project, in my experience, usually have their genesis at the beginning of the project, even though they may be most evident at the end of the project. The dynamic nature of plans is not a reason not to have a plan, and that's perhaps best understood from Sun Tzu's wise words, which explain better than most why you need a plan. And it's also noteworthy that a plan's the first part of the deeming cycle of operational excellence and continuous improvement. A reminder that plans are required in all aspects of life, and projects are no different. As we've all been told many times, time equals money. Typically in construction work, fixed costs represent at least 20% of all costs, and that'll be made up of MOB and DMOB. your cranes, your scaffolds, and your general access ways, security and safety provision, management and supervision, procurement and expediting, and the site services that are required from before the day you start until after the day you finish. And to illustrate this, I've prepared this very, very simple slide which shows a 12-period project which has a cost, a variable cost of 8 squares and a fixed cost of 2 squares. So the 12 periods have a total cost of 128 squares. And when you extend those 12 periods out to 16 periods, then providing you don't change the work that you're doing, then the project variable costs, the yellow section simply moves to where the green section is, and there's no change to the variable costs. However, the fixed costs, as described earlier, they're time dependent and they continue on for an extra 4 periods, so you end up with 8 extra squares. In essence, you end up with 7% additional project costs simply because you extended the project life without doing any different work. And in real life, it'll be worse than that, because in real life you will end up doing extra work as well. But it really highlights that there's a major cost associated with project delays. So what makes a good project manager? Well, he or she needs to be an effective leader. They need to be a people person. They need to be an experienced general. No one wants to go into war with led by the junior subaltern. So we need someone who's done it or something very like it before. They need to have tuned antennas so that they can pick things up quickly, and they need to take action. Hindsight is a fantastic thing. Afterwards, we're surrounded by experts, and it's useful to think about hindsight, because one of the things that can help you with projects is to encourage critical peer review. You know, fatal flaws analysis, expert review, and don't ignore the more pesky critiques. You may not like the way the person's put it to you, but if they know what they're talking about, then you should listen to them. And then remember that a good leader, a good plan, and a good planner is really just a good start. The plan needs to be comprehensive, and particularly for larger projects, which tend to be more complex. The plan needs to be structured to avoid getting lost in the weeds. The standard formats for the structure, the standard mining project plan formats, and they provide a baseline expectation. Also, the PMBOK guide provides an exhaustive list. This list that is on your slide is really just my list of key headings that I would go to as a starting point before checking back of what I've missed out. So these are some of the things I focus on early in a project. With mining projects, they tend to follow a sequence of studies, concepts being explored at high level, so that you eliminate the least attractive options, then scoping studies providing definition and identifying trade-off study requirements, all studies should be subjected to fatal flaw and peer review. The studies are a formal means of communicating the project objectives and plan to a wider audience of stakeholders, and that makes them very valuable. Evaluation and optimization of opportunities, risks and alternatives is absolutely essential, and studies are a key part of that. And the formal presentation actually facilitates your peer review and your risk analyses and so on. Feasibility shortcuts are penny wise and pound foolish. Design is a very expensive process with many highly skilled people involved. There will be more than 40 people in an average size mining project involved during the detailed design process. They will be your mine design team, there'll be a metallurgical design and test work team, there'll be a set of engineering team based on looking at the beneficiation plant, perhaps even further treatment and infrastructure, and then there's the tailings dam team looking at the storage and also waste storage. So you have more than 40 people, all highly paid, all highly skilled, working on an iterative process, which is what design is. And if they don't start from a very clear scope and a very clear understanding of what the interfaces are and what they're doing, then they're going to do a lot of circle work and it's going to cost you a lot of money. So don't skip the feasibility. It provides an opportunity to explore the project planning in detail, including pioneer work and other works which are going to be very site dependent. It should prepare the ground for a successful project by presenting a comprehensive project implementation plan. The various stages of feasibility should progressively flesh out the plan, including the identification of the early works, and ensure an efficient and orderly progress of site mobilisation and groundbreaking works. And also will consider things like local social issues, the environment, weather. All those things are important. Concept and scoping studies identify knowledge gaps. So they are right at the very beginning. They assess the geology, mining, metallurgy, infrastructure, interested parties, regulatory impediments, and a list of other things. So they identify all the stakeholders and their interests. And they also identify options and recommend those options that should be further examined in separate option studies to be completed prior to the feasibility. Feasibility studies identify the optimised mining boundaries, pit shells, underground mine extents of the extractable reserves. They identify all the modifying factors to establish those reserves. They identify metallurgical behaviour of the ore based on representative samples of the ore domains. These studies identify cost and time duration to establish the mine and associated infrastructure required to present a product to market. And in cases where the product isn't an LME traded commodity, they will include marketing studies and product definition so that you explore the markets that are actually available to establish a revenue stream, which obviously is going to be needed. So we got a plan, but something went wrong. The plan can lack critical detail, no geotechnical studies, ore samples tested not being representative of the ore that's going to be extracted, no materials handling studies, inadequate survey with different surveys with different coordinate systems. You know, all these things really need to be sorted out well before the project implementation. Changes to the plan. You know, the first month of implementation and all, we're going to actually increase the throughput of the plant. It's not as uncommon as it should be. Minor changes late in the plan. You know, 3 months into the design and all, we're going to add an extra stage of comminution, or we're going to take one out, or we're going to add an extra stage of flotation. We need more cleaners, or we actually need a, you know, we're going to get more revenue if we put in a special molybdenum circuit or whatever. Limited only, you know, myriad possibilities, limited only by the imagination of a process engineer. The process engineer needs to be put to bed at the end of the feasibility study and not woken up until you're ready to commission the plant. The people issues that can occur, common examples, going to tender without any pre-qualification, which ends up more or less forcing you to take the lowest price, and then discovering that, you know, the contractor can't do the job. Lack of skills available, poor choices of personnel based on poor selection criteria, poor team dynamics. That's clearly what we're addressing in this slide here. We've got two leaders here, clearly effective leaders because they've got to the role, but perhaps not the guys you'd want to implement your project. You know, you've got one who's a master of announcement and another who's a master of good ideas, or at least he thinks they are, but neither of them have got an implementation bone in their body, and so you would not expect things to go well. And then there's planning errors, insufficient float in the plan, emissions in the plan, optimistic assumptions, which we'll come back to shortly, and then sequencing problems that flow from all of that. So optimism is a pervasive problem in project planning. You know, everybody wants their project to proceed. One of the things to recognise is we're looking at the people who are involved in project evaluation. Almost all of them have serious conflicts of interest. The promoters, you know, their reward is in getting the project up and running. Contractors who are helping to provide estimates, you know, they want to get the project to the next stage so that they can win that work. And of course, employees. And employees is perhaps the one that's most often overlooked, because, you know, the promoters, if they get the project up and running and it's a dismal failure, they have to live with it, or at least they have to, they're very closely associated with it, and it's, you know, difficult for them to escape. Contractors may not get paid, but employees tend to get paid and tend to be able to move on. So if we recognise that we have this this pervasive optimism that's fed by serious conflicts of interest, then it highlights the need to critically assess independently projects. And I mean, obviously banks and financiers do that, but you don't want to get to that stage before you find the problem. It's worth remembering that there's often insufficient funds in the early phases of a project to allow for rigorous approach to estimation. And so you end up with some educated guesses, for want of a better description. They may be well informed, but they're still guesses, and you just need to remember that. So it's a human condition. We all want to believe in things. For some of us, it's eternal life and religion. For others, it's the commercial magic pudding. We need to increase project scrutiny if we want to be sure of success. We need to use formal and recognised estimating tools and benchmarking. And the American Association of Cost Engineers systems are published in the AusIMM Monograph 27, and it's readily available, and it's a very useful tool. We should peer review and check fatal flaws in all studies. We should choose proven equipment, pre-qualified suppliers, systems that we know work, and designs that we've seen before if possible. Now, the team doing the job is very critical. The fish rots from the head. The leader will set the culture. If he or she is lacking in integrity and courage, if he or she takes credit for everything but blames subordinates for anything that goes wrong, then things aren't likely to go well. The outcome's unlikely to be a success. It's interesting looking at this slide that there's so many things in that slide that won't appear in a job description, but they are very important in terms of the quality of people that you have in your team. One day through the primeval wood, a calf walked home, as good calves should, but he made a trail all bent askew, a crooked trail, as all calves do. Since then, 300 years have fled, and I infer the calf is dead. But he still left behind his trail, and thereby hangs my moral tale. For men are prone to go up blind along the calf paths of the mind, and work away from sun to sun to do what other men have done. They follow in the beaten track, in and out and forth and back, and still the same course they pursue to keep the path that others do. They keep the path a sacred groove along which all their lives do move. It's a famous poem by Samuel Foss, and it goes to this issue of blindly following systems without understanding what you're trying to achieve. And it won't be important providing nothing goes wrong, but understanding the core system requirements is usually very important when things go wrong. So understand what you're trying to achieve. And one of the best ways of knowing what's going on is using earned value management and the S-curve. Because when you're trying to manage and control, you need to avoid having to chase around after the information. The information needs to be pushed to you. You manage your systems and tools to get the information to come to you. And if that's happening, you can get sick, someone else can come in, the information's all there, happy days, project moves on. So the earned value management system is very simple. You start off with a project budget that has a timeline, a deliverables timeline, and milestones in that timeline that can be measured. And then you have the actual costs of performing the work as you go along, and a good accrual accounting system is going to do that. Probably one of the major issues with your accounting system is to make sure that you set up your account structure to feed into your eventual asset register for your mine. And there is plenty of people around that can give you advice on that. But the important thing is that you measure your expenditure as you're going, as it's committed. And then you align that expenditure with the planned value. And that's not greatly difficult to do. The more challenging aspect of it is the earned value. And best to think of that as, you know, in terms of building a house, you know, your planned value might be that you're going to clear the block and then pour the slab and then build the walls, build the roof, do the internal fit out, and then the handover. And all those things will have values ascribed to them, and they'll appear on the green line there. When you come to the earned value, the slab's been poured, a certain amount of money is considered to be earned, but you know, there might be some parts of the slab, perhaps the garage hasn't been poured yet, so there's a subjective assessment to be made. You know, the walls are all up except the garage walls aren't up, or the shed out the back isn't up, or whatever. There's 1,000 variations that have to be dealt with because the sequence doesn't end up being exactly the same as the sequence that the plan had. So you have an element of subjective assessment in the earned value, and that leads us to the tale of Donald Crowhurst. And it should be, this is a tale that should be etched in every project manager's memory. It's a tragic tale. It's a story of a race that was organised by a couple of newspapers in the UK in 1968, the year following the Gypsy Moth and Francis Chichester sailing around the world. So they organised this around the world sailing competition, and a bit of a Walter Mitty character, Donald Crowhurst, convinced a wealthy backer to sponsor him in the race, and he built a boat which he subsequently took out for seaworthy tests in the British Channel, English Channel, and unfortunately the seaworthy test didn't go well, but he'd run out of time. He had to start or he had to pull out, so he decided to start, knowing he'd mortgaged his house and against the sponsorship money, and he made that fateful decision to soldier on. He could have given up and perhaps faced financial ruin, or he could attempt to sail around the world against impossible odds, which he decided to do. He started to take water within 2 days, and within a couple of weeks he'd started 2 logs, and he was radioing in false positions which followed the blue line, while the other log was the true log of where he went. It didn't end well. It's been made into a movie called The Mercy, starring Colin Firth, and I'll leave it to you to watch the movie. The message is measure your progress, don't make it up. And what's the relevance to this? Well, this is what happens in projects, and this is an extreme example where, you know, I've falsified the earned value with the blue line just under the red line, and then I've got to the stage where I need to put the roof on, but you know, the walls that I claimed were finished aren't really ready, and so I flatline for a whole series of, you know, periods while I finish what I've said I've finished, but I haven't. You don't often see it as extreme as this, but you'll quite often see a project starting to flatline, 3 or 4 months in, and it's because of the project manager basically claiming work that hasn't really been done. One of the other things that quite commonly happens is that the project manager will complain that the measures aren't a really accurate assessment of what's going on, and he wants to modify the measures. My answer to that is that if the measures are under-reporting project progress, then that will become evident soon enough. Don't worry about that. Just get on with doing the project. The real value of this system is that if you're having problems, it's really obvious, and providing you reporting honestly, everybody can see it, and you can get many eyes on the problem early, and that means that there's a better chance of fixing the problems. And if the problems can't be fixed, if it's going to go over budget and it's not going to correct itself, then at least the owner has early warning that they need to get out and raise some funds. And the longer the lead time for that, the better. So design, which is it's the beginning of every project, because until you know what you're doing, you don't know what you're doing. It's also one of the opportunities for early works and for project de-risking. It's really something worth considering. Good design will cost you about 8% of the project value, and that sounds like a lot of money for some paper. What you need to keep in mind is that bad design will cost you the whole damn lot. Bad design wastes everything that comes after it. So it's worth remembering that design is always on the critical path. Doing design early de-risks. One of the other issues about design is that it's iterative. It looks simple. It's not simple. If it was simple, you wouldn't have bad designs. You don't know all the things that are going to change when you change a design until you make the change and bring all the issues back to bear on the starting point. And it's invariably causes more work when you change design than anybody expects. So this summary and recommendations won't guarantee you a successful project, but it will provide you with a good start. There are many other aspects of projects that need to be done well in order to achieve a successful project outcome. And that includes quality assurance, safety awareness, community and social responsibility, and many, many others. Operational readiness is one that particularly comes to mind because the quality of the operational team and the quality of the planning for that team to take over from the project initiation and construction team, will have an absolutely huge impact on the project outcome. I've always said a good operator trumps a good engineer every day. An average engineering outcome can be turned into an outstanding operational outcome with good operations people and a good team. So I've chosen to discuss those aspects of projects with which I'm most familiar, and that's the early stages where I've got the most experience, particularly in recent years. So that's it. I've finished my presentation.
Thank you for that, Tom. We have a couple of questions from the attendees, and the first one relates to float. Tom, could you just clarify how you propose to handle float? Because we are told that the critical path by definition has zero float, and if you could just clarify your thinking on that.
Yeah, the thing about critical path is that it's looking at the shortest duration through to project completion. And what you've got to be careful of is how you look at your task definition. So if you've optimistically assessed the duration of every task, let's say that you think you've got a 50% chance of completing tasks in the time that you've allocated for them, then what will happen is that every time there's a that expectation isn't met, if you like, and that task is on the critical path, then you're going to end up with a project that's late. So what you need to do is you need to actually have in your mind that you are going to select task durations that are 90% or better chance of achievement, right? And then you need to, within your tasks, have sufficient float to allow sequencing to occur. You cannot run a schedule based on no float.
Thanks, Tom, for that clarification. We have one more question here. This one's maybe a little bit controversial, Tom. Can you give an example of a project where the met test samples were not representative of the ore?
Yeah, there's lots of minor examples, but every now and again there's a spectacular example, and to this day I don't know why the ore body didn't behave as people expected it to. But the Wedgetail mine in Nullagine turned up unexpectedly high proportion of refractory ore, which in the end, I guess, it probably destroyed the project, to be honest. The project limped on for a number of years, but it was never the project it was supposed to be. And the main reason for that was that the ore body had a considerably higher proportion of refractory ore than was reported in the feasibility studies and was designed for. So there was the ore was designed, or the plant was designed for a free milling ore, and then it turned out to be refractory.
Right, not a good situation.
There's plenty of examples where the grade doesn't turn up, but that's not necessarily to do with the metallurgical sampling. That's usually geological interpretation. But yeah, that was an unusual one.
Yeah, quite an extreme one. Well, I think that's all the questions. So on that note, we will close the webinar, and thank you very much, Tom, for an excellent presentation. I hope everyone enjoyed it, and thank you for your attendance. Bye then.